Hello everyone, hope all of you doing good. In this segment, we'll be happy to discuss something related to how to calculate the hydrostatic force for the inclined plane surface which is submerged in liquid. Let us try to imagine one such inclined plane surface. This is the free surface. Let it be an irregular body which is inclined and then it is submerged in a liquid. Let me consider two planes. One is this, and perpendicular to this is the other plane. So theta may be the inclination with respect to the free surface, the same inclination which is expressed with respect to the horizontal surface. Okay, as usual, we'll try to go with 2 points G and P. G is center of gravity, P is center of pressure, and an elemental strip with B as the width and DH as the thickness. So this is the rectangular strip where we can directly calculate the small area as dA, and dA is nothing but B into DH. Okay, now on the other plane, if you just observe this inclination or inclined surface, this is how it looks. And for this elemental strip, the perfect vertical depth would be h. To the point G, it is h bar, and from the free surface to point P, it is h star. Now the same things can be measured with respect to another axis, y bar and y star. Now just try to understand the differences between h bar, y bar, and h star, y star. They are separated at least by 90 degrees. So F is that force, hydrostatic force, which is acting at point P. P is the center of pressure. Okay, now let us try to go with the usual practice where P is the intensity of pressure, which is gamma into H. Gamma is rho into G. Now let me consider this microscopic element, and which has B as the width and DH as the thickness. So dA is B into DH. I hope you have understood this. Now what is DF? The small amount of force. Is it not P into dA? Yes, it is. But at the same time, if you just observe here, uh, across these two lines, you have one angle which is theta, and you have h bar, h star, and you also have the diagonal elements as y bar, y star. You could imagine three right angle triangles with theta as one of the angles. Now from this one can write that sine theta is equals to h by y sine theta. The same sine theta is equals to h bar by y bar, and the same sine theta is equals to h star by y star. Hence you could follow this a very simple equation, h by y equals to h bar by y bar, which is equals to h star by y star, which is equals to sine theta. Now where do we use this equation? Whenever we need to convert this h to y equivalent, h bar to y bar equivalent, h star to y star equivalent, we could go with this equation. So for example, h is nothing but y sine theta. Similarly, we can also write h bar equals to y bar sine theta, h star equals to y star sine theta, or the vice versa. The relation is also true. Okay, uh, we were in df equals to p into dA. And what is P here? Intensity of pressure. It's rho into G into H. But what is H? H is Y sine theta. Try to understand this simple substitution here. H is Y sine theta, and rest of the things are same, B into DH. But what is B into DH? Once again, it's dA. And F is nothing but the total pressure is the integration of those small pressures, dF. But what is dF? Is it not rho g y sine theta into bdh? Yes, and hence you could also take certain constants here. One is rho g, the other one is sine theta. So rho g sine theta, integration of y into dA. But integration of y into dA is moment of surface about free surface of liquid, and that's about A into Y bar. Now, Y bar can be converted into its equivalent H bar by using this angle theta. So F equals to rho G sine theta into Y bar A. Now, sine theta into Y bar has some more meaning. H bar is Y bar sine theta. So instead of Y bar sine theta, one can substitute H bar directly here. So as usual, and as compared with that of the horizontal case, vertical case, even this equation holds good for the inclined surfaces. So F equals to rho G A H bar. We are done with the 50% of work. The next would be to calculate position of center of pressure, where exactly P is located, where exactly the total hydrostatic pressures are acting, that is the location of P or F. So we go with the same simplistic approach of considering the moments, the principle of moment. So we would try to take the moment of the force or the forces about OVO axis. This is the OVO axis. From this, if you take the moment of F, it's F into the perpendicular distance, that is about Y star, and that's equals to all those forces which are rooted from the elemental strip, which is having width as P and the depth or the thickness as dH. So it's integration of dF into Y. You should understand that there are n number of forces which are summarized in terms of integration of dF into Y. Okay, so what is dF? It's rho g y sine theta dA into already existing y, the integration. So if you further simplify it, you get rho g sine theta into integration of y square dA. So integration of y square dA is nothing but I naught moment of inertia. So the same thing, but at the same time we also know that y star equals to h star by sine theta. So we could very easily convert the values of y star and h star. At the same time, we also know another fact of I naught equals to Ig plus A y bar square. So we'd convert I naught to Ig here, and using these two relations, and H bar being y bar sine theta and y bar being H bar by sine theta. The next step would be H star equals to, from this y star is converted into H star, and H star is sine square theta. You have one sine theta here on the denominator part of left hand side, which goes to the right hand side, the numerator, it becomes sine square theta by AH bar into Ig plus AY bar square. So upon the simplification, which may take one or two steps once again here, H star becomes equals to Ig sine square theta by AH bar plus H bar. Now once again, H star is more than H bar, at least with this fraction. And if you remember, for a vertical surface, the formula was H star equals to Ig by AH bar plus H bar. And exactly if you substitute a value of theta equals to 90 degrees, sine square theta tends to become 1, and that's exactly the case of vertical surfaces. And just to summarize, F in the inclined case, F equals to rho g A H bar, and H star is equals to Ig sine square theta by A H bar plus H bar. Thank you.